mathematicians, welcome to my math class. In this video, we will be discussing the definition of the different properties of binary function.
Binary function, from the word itself, binary, it involves two quantities or two terms, such that it is any operation that combines two values to create a new one. It is often denoted by symbols like star, plus, times, or circle.
The most common binary operations are the four basic operations, which are addition, subtraction, multiplication, and division. All of them combines two numbers in order to create a new value.
Now, without further ado, let us discuss the different properties of binary function.
First, let us have the commutative property. A binary operation star on a set S is commutative if the order of the operands does not affect the result. For all elements A and B in set S, the operation star of A and B is equal to the operation star of B and A. Take note that the star symbol here is just a placeholder for the operation. So if the operation is addition, then A star B is read as A plus B. Examples of these are the addition of integers and multiplication of real numbers. However, subtraction is not applicable here. Here's why. If we let A equals 5 and B equals 6, then negative 1 is not equal to 1. This is why subtraction is not a commutative. Next, let's have the associative property. A binary operation star is associative if grouping of operands does not affect the result. For all elements A, B, and C in set S, the operation star of A and B and C is equal to the operation star of A and the operation star of B and C. Addition and multiplication of integers are also associative, but subtraction and division are not applicable here. Here's why. If we let A equals 3, B equals 2, and C equals 4, and substitute it, then solve it, then negative 3 is not equal to 5. That is why they are not considered as associative. Now let us have the distributive property. A binary operation is distributive over another operation circle if applying to an operand and the result of circle is the same as applying stars separately and then combining. Take note that the symbol circle here represents a second operation. So if symbol star represents multiplication, then symbol circle represents addition. Here how it works. Multiplication distributes over addition in integers. Therefore, addition does not distribute over multiplication. Let's break it down. Let's say A equals 3, B equals 4, and C equals 2. If we are going to substitute, distribute, and solve it, then 18 is equal to 18. Lastly, let's have the inverse property. An element A belonging to set S has an inverse with respect to a binary operation star if there exists an element B belonging to set S such that combining them yields the identity element. If E is the identity element under star, then A star B equals B star A equals E. For example, in addition over integers, the inverse of A is negative A, since A plus negative A equals 0. In multiplication over non-zero real numbers, the inverse of A is 1 over A, since A times 1 over A equals 1. Take note that not all elements always have inverses. For example, 0 has no multiplicative inverse. Let us dive deeply. For example, in the set of real numbers R, every non-zero number has a multiplicative inverse. For instance, the inverse of 5 is 1 over 5 because 5 times 1 over 5 is equal to 1. But 0 has no multiplicative inverse. If we try to find a number x such that 0 times x equals 1, it's impossible because 0 times x is equal to 0 for all x. Therefore, 0 does not have a multiplicative inverse. To easily understand it, here's the keywords. So I guess that's all for today. Thank you so much for watching and listening. Bye!